Hello everyone, welcome to this new video tutorial on ArcGIS for beginner. In this tutorial we are going to learn some beginners tool about the ArcGIS software, and we'll be doing some spatial analysis using these tools and some data related to the Geographic Information System, some spatial database. So before going to our tutorial, we'll quickly review about the GIS system. So what is GIS? So basically GIS is a computer system which is used for capturing, storing, checking and displaying data related to position on the earth surface. So position on the earth surface is referred as spatial database, which gives the location of individual data on the earth. And this geographical information GIS is a powerful tool which is used for various purposes, that may be mapping, telecom and network services, maybe on accident analysis and hotspot analysis, on urban planning and transportation planning, and environmental impact analysis, agricultural applications, and disaster management and mitigation, and many more. There are many more applications of GIS. So for the process of GIS analysis, there are basically 5 components. These are hardware, software, data, methods, and procedure, and people. The hardware includes the satellite constellation, surveying instrument, that may be TS, that may be GPS devices, and computers, and data storage. And the software which are open source software and licensed software. Open source software involves QGIS, that is Quantum GIS, and licensed software, that is ArcGIS, ArcGIS Pro, and many other licensed software are available. And for the data we mainly use raster data and vector data. And then for the method and process, we may be using various methods and procedure for spatial analysis, that is for example route finding, that is overlaying. And the ultimate goal of the GIS analysis is for producing a better output, and that may be used by the people who may be users, developers, and many other organizations that needs the spatial analysis data. So for the case of spatial analysis, we mainly deal with raster data and vector data. In vector data there are 3 types of data, that is point, line, and polygon. The point indicates the individual point data, line may be road, river, etc., and area may be the forest area, settlement area, and etc. And raster represents the individual value in the form of cell, that is pixel. Each pixel represents some value, and the collection of this pixel is known as raster data. Raster data may be photograph, satellite imagery, drone data, etc. So let's go to our course content, what we will be learning throughout this video. So for the first we'll learn about the ArcGIS interface. We'll learn about the ArcMap user interface, where we'll be doing spatial analysis, what are the tools, how can we make our analysis smooth and fast through different tools available in ArcGIS software. Mainly we'll be using ArcGIS 10.8. If you have installed lower version, it is also sufficient. So after the interface introduction, we'll be working with vector data. So we'll work with vector data. At first we'll learn how to insert vector data in our ArcMap map view, and inside the ArcMap we'll be learning about the attribute table. So inside the attribute table we'll learn about the various spatial data and non-spatial data of our given data, and then we'll learn about styling and labeling the vector data. So we'll give different symbology and labeling features available in GIS software. After that we will do geoprocessing tool, that are clip, intersect, union, dissolve, and buffer. So after completing this geoprocessing tool, we'll also learn something about Google Earth Pro. We'll learn how to Digitize and Google Earth Pro will digitize point, line and polygon on Google Earth Pro, and will export this Google Earth Pro data and use GIS to import this data in our GIS software, and we'll work on that. After that, we'll also work on selecting the individual information available on our data with by attribute data or location data. That is, attribute refers to non-spatial data and location refers to spatial data. After that, we'll also export that selected data in ESRI Shapefile format. Also, we'll also learn about calculating some geometrical properties, that may be area or length, etc. Also, after that, we'll also work on some digitization. We'll use satellite imagery and digitize this data available on our image. So we'll create some point, line and polygon through digitization process. After that, we'll work with the tabular data. We may be working with TIS data available with us. So the data was obtained from TS, total station survey, and these are point data. We'll be importing this point data and we'll see the spatial location in ArcGIS, and we'll also work some labeling this point data in ArcGIS. After that, we'll work on raster data. So we'll first add a raster file format in ArcGIS. For this tutorial, we'll be using DEM data available from SRTM. SRTM DEM will be using SRTM DEM, which is about 30-meter resolution. So after that, we'll also work on styling this raster data, giving symbology to the raster data. After that, we'll work on extraction by mask, similar to the clip function in vector data. After this, we'll also do some terrain analysis. We'll create slope, aspect, hillshade from the DEM data. After this, we'll also work on creating the contour and DEM from the CSV data previously obtained from total station, and then we'll also work on raster to vector conversion. At last, we'll create this beautiful map layout from ArcGIS and conclude our tutorial. So let's start our video. Okay, so we are going to start our tutorial on ArcGIS. This is the interface that you will see when you open the ArcMap folder. So first thing, when you are working on the new project, the first and ultimate thing that you must do is to create a blank map. So this you can see this option, or you can go to file and create a new blank map on ArcGIS. So after that, you can see here are the layer functions. So this layer are those this table of content is the area where you will be dealing with all the data layers that you will be working on the spatial analysis. You can import all the layers and you can randomly select that data and work on this data. So you can see at the top, you can see edit, view, bookmarks, insert, selection, geoprocessing. These are different functionalities available on ArcGIS, and you can see the shortcut buttons also here. After that, you can see on the right side of the this portion, you can see is the map view portion. Every data and every map is shown in this view. Here you can see the map available on your database. So after that, you can see this catalog. The catalog is the portion that makes you easier to import all the map data you have in your computer system. You can connect to the folder where you have kept all your data and then import easily in the ArcGIS. So we'll also learn about how to connect to the folder with at some time. Before that, let's go to the Arc toolbox. Here you can see I have catalog, and then here I have Arc toolbox. Okay. Here there are various spatial analysis tool in ArcGIS inside the Arc toolbox that we will be dealing with in our tutorial video. So there are many tools that you can explore after learning this beginner tutorial, and you can see here source option. So if you don't have if you don't know where to find all the tools, you can directly search from here. So after searching, maybe I will search with clip, and then after searching you can see clip, and then you can directly use that tools in ArcGIS. So there are many tools, other tools. Okay, so after that, this is the map view, and you can go to layout view. This is the layout view where you will be dealing with the map, final printable map. You will create a whole map, you will insert the legend bar, you will insert the title, you will insert the north arrow, you will insert everything that you need to create a beautiful and quality map, and you will export that map for the further printing process. So in case of introduction of user interface of the ArcMap, this is sufficient. You will also learn everything when you go with this video. So without delay, let's go to our main topic. The first topic is working with vector data. So before working with vector data, let's learn about what is vector data. So in case of vector data, we'll be learning about point, line and polygon. So in case of vector analysis, I have given all the data that we'll be using throughout this video in the link in the description. You can find the drive link in the description and download all the data. So for that case, I have the training data. So we'll be using this training data throughout the training sessions. So first of all, you just need to know how to import each and every data in ArcGIS in the form of vector format. We may have Shapefile format, GPX file format that is obtained from GPS devices. After that, we may have KML file format, KMZ file format that will obtain from Google Earth Pro. These are the vector file format, and to import this vector file format, the first thing we need to do is you have to go to ArcMap, and you can see this function add data. Inside add data, you can click on this, and the first thing is we need to connect to the folder that has the data. So I'll click on connect, and then I'll go to the folder where I have saved all my data. So this is the folder where I have the training data. So I'll click on training and then click OK. So after that, I'll go to here and then go to the folder that I have connected just now. So I don't see any folder. Let me connect once again. Okay, so I have connected to the folder, and after that I'll go with the training, and I'll go with inside the shape file. You can see harness NPL WGS 3, 4, 5, 6. These are the individual shape file. These 4 represent the local level data, sorry, world level data. This represent the local municipality or metropolitan, etc. local government data. This represents the district level data. This represents province level, and this represents whole country data. So in this case I'll insert to wgs2.ssp. This is the district data. So I'll click this and I'll add this data. So after that you can see, and this is the map of the Nepal. So in this way you can see the map is added in our GIS. So after that we need to see the what individual boxes this polygon, this irregular polygon represents on the map. So for that case we'll click on this layer. So before this you need to go make sure that this is on this portion, list by drawing order, or you may go anywhere. So I prefer this list by order so that we can arrange our data easily. So after that right click on this and go to open attribute table. Here you can see the attribute of the individual irregular boxes. So you can see the individual district name and then which province it refers to. Okay, so this is number wise and this is name, province name. And when you select this here you can see the individual district is selected in the map also. So when I change this, okay, this is shown in this map, this might be here, and by this like this you can see individual data shown on the map. Okay, so after this is selected, so to unselect this you can click on this clear selected feature and this will clear the selection. Okay, this is for the attribute. After that we'll go to styling and labeling our vector data. So you can see in attribute table there is a label of individual district name and the individual polygon is associated with their district name. So now we'll go on labeling this individual district. So for that case what we'll do is we'll go to properties. Inside the properties you can see labels, and then here label field is PR name. We'll select this and make this as district. After that apply and then OK. So after that we'll go on label features. So enable this label features and you will see individual district name seen on the individual district. So after that you can also modify the properties of the label. So you can change the font size, so I'll change the font size to 6 and then apply. So in this way you can change the color and font size and everything of the label. After that I will again click on this label feature and this label is gone. So in this way you can label your individual data and vector data and GIS. So after that we'll go on symbolizing color, changing the color of our map. So you can do by two ways, either by clicking directly on this and changing the individual color. Okay, like this you can change the individual color of your district, or other is you can go to selecting this and then go to properties. Inside the properties you can go to Symbology and then you can change the symbol. Okay, after that also you can change the symbol according to the assign the symbol according to the categories. Maybe I'll go with the province. I'll assign different color to different province. That is, I'll add the province, select the province and add all the values. So maybe province name and add all the values. So individual province will be given color, different color. So I can select the color which I will assign. So in this way you can select the province and then give different color to individual province. So in this way you can change the symbology of your data. So after that, the symbology portion and labeling portion is done. Okay, after that we'll go on to connecting our folder from catalog. So inside the catalog you can see here is the connect to folder option. So from this also you can connect to the folder. So I'll be connecting to my folder and I'll then click on then okay. So you can see my connected folder is here. So after that, for the process of geoprocessing tool, we'll go to the first tool is clip. So for the case of clip, we have here you can see Nepal data, and then I will first import cascade.shp, and then I'll next import major river.shp. So you can see you can make the color also hollow. You can see this hollow option so that you can see what is beyond this polygon. So here you have two shape files. One is of major rivers of Nepal and another is Cascade district of Nepal. So what we are going to do is we'll clip every river that is inside this Cascade district. We'll clip out all the rivers that are outside the Cascade district. So after clipping, we'll only have the district that is inside the polygon. The outside the polygon river will be deleted, clipped out. So you can go to geoprocessing. So before that, let me create a new folder here at my training data where I'll be saving all my exported data. So I'll create a new folder and I will name it as training output. So we'll go with geoprocessing and then clip. So you can see what clip refers to here. You can see inside the okay. So here we have, this is the input feature, this is the clip feature, and we'll have the feature that is only inside this polygon. So this is the clip feature. So for the input feature we'll import major rivers. So you can select on this and import major rivers. Sorry, this. So inside the clip feature we'll be using our boundary, that is Cascade, and we'll save our data in the connected folder. We have the folder connection, that is training data. Inside training data we have training output, and we will save apps clip.shp. This shp, this is the file format, vector file format, that is .shp is save file format. So we'll save as .shp and then save. Okay, after this click OK. So after this you can see you can remove the previous data. You can remove this major rivers, and then we have Cascade boundaries and this clip. So you can see here only the major river inside the Cascade district is shown here. The other are clipped out. So this is the property of clip. So after that you can click on this and remove the this data from the map view. After that, the second part is intersect. So talking about the intersect, you might have seen this in set in mathematics. You can see the intersect refers to the common portion between two types of set. So the A union B, A intersection B refers to the intersection. So similarly in this GIS, same is about the intersection. So for this I have two types of data. One is int.shp. The second is 2int.shp. So here we can see in one int and 2int, you can see the one district is common. That is this district is common in both. So when we use the intersection property in intersection geoprocessing tool, this portion will only be seen and other will be removed. That is, this is the intersecting portion between the two shape files. So we'll be using intersect. So we go to geoprocessing tool and then intersect, and then input feature. Both will be the input feature. First we'll select int and then second 2int, and then we'll save this in intersect.shp and then save. Okay, this is the intersected portion between the two shape files. You can see this is only the intersected portion between the two shape files. So after that we'll go to dissolve. So for the process of dissolve, you will go with the data that is inside this shapefile. You will go with 3 minus NPL 3. So here you can see we have municipality level data, local government level data. So what we'll do is we'll dissolve all the local government data into district data. So we need only the district shapefile, but we have district boundary, but we have the boundary of local government. So for this case, what we'll do is we'll go to dissolve. Inside the dissolve, we'll input feature. What is the input feature? Our input feature is our which individual data. This is the input feature, and what we will dissolve it, we'll save it as dissolve.shp, and then we'll dissolve on the basis of our municipality, that is Palika, and then click on OK. Sorry. We'll dissolve so on the basis of the district, we will dissolve on the basis of district. So in this way you can see all the before it was of municipality level, now we have got of district level. So in this way we can use dissolve. Okay, after that what we will do is we'll go with buffer. So you may think when buffer can be used in practical life. So talking about the practical implication of buffer is one example is you may be near the river and you might be afraid of the flood, which the buffer zone about the river. When the flood level increases, what will be the area from the river, what will be the length from the distance from the river that will be covered on the flood. So for that case you might need the buffer zone. So what we'll do is we'll use the clip data of this river of Kaski, and then we'll create a buffer that is maybe 50 meter of the distance from the river, buffer distance from the river. So for that case we'll use buffer, and then what we'll use input feature is clipped. So after that we'll create a buffer buffer.shp save, and then we'll do linear unit. We'll use 10 maybe 1 kilometer or maybe 500 meter, and then we'll click on OK. So this is the 500 meter below and above the. Okay, let me take this to the top, and then you can see here this is the 500 meter above the river and below the river area, left and right side of the river area. This is 500 meter left and right. This is the buffer zone of the river. In this way you can create a buffer for the river. Similarly, in case of point, you can create a buffer zone, that is maybe the radius 100 meter radius or 1000 meter radius around the headquarter of the district. Like that you can create a buffer for any type of data. So after that we'll go on next part, and that is we dealt with, in this case we dealt with .ssp format. Now we'll go with Google Earth Pro. In Google Earth Pro will digitize and then import that data in our export the data in our training folder, and then we'll import that data in ArcGIS. Maybe I'll go here and I'll show you how to digitize. Okay, so we are at this place. So what we'll do is, the first thing you need to go is to you can go to temporary places and then create a new. Okay, so my place is add folder, so I'll fold it as GIS training. So inside the training folder we'll first create a point. So for the point we'll select this folder, and then we'll go to this option. Here you can see add a place mark. So I'll select and drag this place here, and maybe name this as lake. Then click on OK. You can change the color, shape, size of this icon. Then click on OK. So the next part is I'll go to add a polygon. So maybe digitizing the building. I'll click on 4 corner of the building. So 1, 2, 3, 4, and then maybe style area. I'll make this as outlined only, and then outline color will be this. Maybe width, I'll change the width to 2 unit, and then click on OK. If you want to add more polygons, so then click here, then properties, and then add other points here. So for that case I'll undo, and then for the process of creating a path I'll go on this, select add path here, this option, and then this is the path. I'll add this 1 2 3 4 5 like this. Or if you want some smooth, then you can select this, click this and drag your mouse like this. So after that I can change the color and then width of the color and then opacity. So we have altogether added all the three: point, line and polygon. The next part is to export this data. For that I will select this and save place as. Save place as in my training folder. Here I will save as .kml. GIS training, GIS underscore training .kml format. So it is saved. Let me see. So you can see GIS underscore training as KML format. Now we have to add this KML data in our GIS. Before you directly added Shapefile, but in this case we have to convert this KML into Shapefile. So for that case I'll go to search and then search from KML. And then you can see this KML to layer for conversion tool. So click on this. That input KML is. Let me go to the folder where I have saved my data. And then select this. And output folder will be where I have saved all my files before. That is training data. Inside the training data we have training output and will be GIS KML GIS underscore sorry, okay, it will say here add and then I will select as okay. It will create a new layer of KML file. So you can see 3 layers. Okay, so in this map build you can't see this data. So for that I will go to select on this GIS training and select, click on zoom to layer. So in this way you can see 3 types of data you can see on ArcGIS. In this way you can import the data from Google Earth Pro to ArcGIS. Now you can go with the next portion, and that is selection by attribute. So I have this data harness NPL WGS3. Let me go to harness NPL and select, click on zoom to layer. Maybe this is not the data that we want the district data. So for that case I'll go to catalog and select harness NPL 2 and drag here. So in this way you can see, you can select the district data. So from this data let me see my attribute table, and maybe I need Joomla. One technique is directly selecting here and selecting the Joomla, and another technique is you can go to selection and then select by attributes, and inside harness NPL WGS2 I need district equals to get unique values, and maybe I need Bazura, and then I will click, and then I will click on OK. So for this case what we know is, in this layer harness NPL layer, this is the layer This all are layer, individual layer, and in this layer this Bajura district is selected. Now what we have to do is we have to export only this Bajura district. So for that case, what we will do is in this selected layer, in this is the layer and the Bajura district is selected in this layer, which means we can export the Bajura selected layer directly from here. So what we'll do is we'll select this layer and then go to data and then export data. So here what we'll do is we'll browse the folder that where we will be saving our data. So here you can see our folder is training data. In the training data we have training output, and then we'll save as bajura.shp. So after that we'll click on OK. So this asks you whether you want a new map layer or not. So I'll create yes, and you can see a new layer is added to our table of content. You uncheck this, you can see this only Bajura district. After this maybe you can create on the label feature. So here your label feature is on province, so we go to properties and then go on label and change this to district and then apply. So you can see Bajura. This way you can select your district, individual district. Next part is okay, so this is selected, this we will unselect this. The next part is what we want is we want all the neighboring district of Bajura, which means the district that touches the boundary of Bajura. Maybe you can see from this 1 2 3 4 5 6 district touch the boundary of Bajura. So for the case of selection by location, I have this Bajura district, then I'll go to selection by location, and then select feature from harness NPL, and source layer will be Bajura, and then what we'll do is we'll go to touch the boundary of the source layer. So and I'll then apply and then OK. So these are the boundaries, boundary district of Bajura district. This district touch the Bajura district. So in this way you can find the selection by location on ArcGIS, and then you can export that. So after that I'll unselect on this. Now what we'll do is we'll find the area of the individual district. So for the case of area we will be using this data, and before finding the area you need to assign some data frame to the property in this map. For that case click on this anywhere on this map view, here right click and then go to data properties, and inside the coordinate system assign, go to projected coordinate system, world, UTM WGS84 northern hemisphere, and then in case of Nepal it is 44N, and I'll then apply and then OK. So after that I'll go to open attribute table and I'll add a field of area, and that will be float, and then OK. And after that on area I will go to field calculator, and then area I'll be using as square kilometer, and then OK. So this is the area of individual district. So in this way you can find the area. Similarly for the case of length, you will be using length, and it will directly give you the length of individual line segment. After that, we'll go on digitization. So in case of digitization, better is you create a new blank map. So I don't need to save this, so I'll create a new blank map. So here at our training data folder, you can see editing basic, and inside editing basic I have the image colv 2010.jp2. I'll import this image. This is a drone image, and in this we'll learn how to create or digitize our imagery. Before digitization, you need to find out what are the features that you need to digitize. Maybe in this case we need this as a playground, forest, road, buildings, and many other. As the features increases, the layer that you need to add must also be increased. So for the process of digitization, I'll go to training folder. I'll select this and I'll create a new folder that will be this is the next. I don't need I have to go to my own connection folder connection. I'll connect sorry, I can't see my folder connection. Where is it? So here is my folder connection. Inside training data, I'll go to training output and create a new folder that will be digitization. Inside the digitization, what I'll do is I'll create a new shapefile. The name of the shapefile will be first will be place name, that will be point, and I'll give the coordinate system as WGS 1984. Maybe I'll go before that. I'll go to properties and then I will see the coordinate system. Here is the coordinate system NAD. I'll copy this. And then I'll go to new shapefile, that is place, and I'll give the coordinate system and source here. The coordinate system. It's taking some time, and I'll select this and then okay. So you need to give the same coordinate system as that of the satellite imagery or drone imagery, and then click OK. This is the point shapefile place. And the next will be polygon, that may be forest, that will be polygon, and then coordinate system will be same, and then okay. After that, next will be road, that will also be polygon, and then add coordinate system, and then okay. Now what we need to do is we need to start editing. So for that case, what you need to do, you need to go to customize and then toolbar. Inside the toolbar you need to click on this editor. This needs to be clicked on, and after that you can see here, you can see this editor bar, and then select this digitization and then start editing. So after that you can see here this the create feature option on the editor. So click on this and you need to select which feature you need to map. So after this, first of all I'll go to place. Maybe this is the place, and I'll go to point. I'll select the point and add a point here, and then similarly I'll add a point here, and then I will go to save edits. You need to save the point, and after that maybe I will go to forest and then click on polygon, and then I will map this as polygon, and at the last point you will double click, and I will again save the edits. Need to save the edits, individual edits, and I will now go to road, and then that will also be polygon. This way I will go and create an outline of my road. And at last point I will double click, and then editor and save the edits. After that, after I finished creating my all the point, feature and polygon, I'll go to editor and stop editing. So you can see after that you have three types of data here. You can see at layers: place, road and forest. So you can change the symbology accordingly. So for the forest I will give the green, for the road I will give maybe gray, and for the place I will change the symbology as square. So in this way you can create digitize your satellite imagery using ArcGIS. So for the vector data, this is all we have at this beginner session. Remaining we'll learn at our advanced GIS session that I'll bring in my upcoming videos. Now this was for the vector data. Okay, now we'll be working on how to insert CSV data, that is tabular data format, in ArcGIS, and we'll also do some labeling and symbolization styling in this data. So for that case we go to our training data. Through catalog I'll go to training data, and you can see this Excel data, that CSV. I will directly insert this here. In this way you can select your data, or also you can add by another way, that is go to file and add data, that is add XY data, and then here you can select the data Excel data, and then we'll go with string, X as string, Y as northing, and Z as I data. And you can also give coordinate system. For that I will give WGS 1984, and then I'll click on OK. So this way you can add the Excel data, or otherwise if you have added from here from this catalog directly by dragging, you have to go to click on this right, and then go to display XY data. Serial number X field will be listing, Y field northing, and then Z field will be height, and project coordinate system you can give from here. It is WGS 1984 UTM 1044N, and then click on OK. This way you can see the tabular data format shown in your map view. After that you can go to this and go to properties. Before going to properties, we once look at attribute table. We have string, northing, height, remarks, and shape. So remarks is here you can see RL means uh, road left, RC means road corner, RR means road right. These are the data obtained from total station. So it is just remarks, that is shortcut while saving on TS. So for this case, let me save by so the label according to the remarks, and then I'll apply, and then label feature I will enable. So in this way you can see the label feature. Now we can go to properties for one side of this layer feature, and then go to properties. Inside the properties you can see symbology. So while doing digitization, if you just want the road left road and then connect this road left, and again you can take road right and then connect. So here you can see all have the similar type of symbol, but in the case of digitization you need different symbol for different data value. So for that case we will go to properties, and then inside the symbology we will go to categories on the basis of remarks, and then add all values, and then apply. So the individual type of remarks have individual type of category. So let me go with RR, that is road right. I'll change the symbol to circle, and then you can see here the road right you can connect directly within the circle, and then I'll go with road left and I'll change to square. So in this way you can see individual road right and road left have different symbols, and then you can add a data, or you can create a road by connecting this dot at first and then go with square at second. In this way you can create a polygon of a road. So this helps in digitization of TS data. I think with this we have completed our Excel data also, that is tabular data format. Now we'll go to raster data format. So before going to raster data format you need DEM data, that is I have given that in the training data samples. So you can go with Fedicola. Inside the Fedicola you have AP16230 BBS FPS .dem.tif. This TIF is the file format of raster data. So you need TIF data for raster data analysis. You can't do raster data analysis with vector data format. So what I'll do is I'll drag this and import on our ArcGIS. So this is the DEM data. DEM data means digital elevation value data, which gives individual pixel gives the elevation value. This data is obtained by interpolating the elevation value, and then interpolating from the elevation value. So this gives the continuous elevation value of the individual point on the surface of the earth. So I have this DEM data, and then I will also import this fedicola.shp Shapefile, that is our point of interest. So I'll go with this, and then I'll bring this to top. So before in vector data format you might have done with clipping. In clipping you take out the area or feature within the point of interest. So this is our point of interest. I'll make it hollow. Now I'll change the color, outline color to red. So this is our point of interest, and then area of interest, and we all will need DEM data within our area of interest. In case of vector data we did clipping. Inside geoprocessing we had clip option, and then with clip option we did the clipping in vector data format. But in case of raster data format, we must go to search and then search extract by mask. So here you can see inside the special analysis tool you have extract by mask. So it has also given clip. This is for the vector data format. Also raster data format you can do, but it will create a rectangular surface, not exactly at our area of interest, but a rectangular surface. So we will go to extract by mask. Inside the extract by mask you can add the input the raster as their DEM data. And the input raster or feature max data as this, and I'll save this as in our training output. That is okay. Yes, this is the training data, training output. I will add this as fedicola dot. You may have noticed we have used .ssp for our vector data, but for our raster data we will use the file format as .tif. You must always add .tif after your file name and then save, and I'll do okay. So this is our DEM of area of interest. I'll click on this and I'll also click on this, remove this. Now this is the area of interest of our fedicola. So we'll go with adding style. You can see this value from 751 to 2105. This is the elevation value range from 751 meter to 2104 meter. So what we'll go with, we'll go to properties and then symbology. Inside the symbology you can send the color value of the elevation. So I'll add this color and then apply. You can see the elevation value changes from, this is from low to high. I can also change from this and then apply. This is from low to high. Now also you can go with classified value. For that case I'll go with classified, and then I'll break the elevation value into 5 classes. That is this range. Within this range the elevation value will be classified, and then I'll go with different color for different classification value. Maybe this color is suitable for the classification value, but maybe I don't think this. Okay, and then I'll apply. So in this way you can see different elevation value class have different colors. So in this way you can change the color styling of raster data format. Now I'll go with stress value, and I'll go with default black and white. Now what we'll do is we will go with terrain analysis. The first case is we'll go with the slope. So you already know what is meant by slope. The slope is the rate of change of elevation value. In slope we mainly find the difference between the elevation value, how the elevation value changes from one place to another place, that we find as a slope. The slope can be found in 2 ways, that is, one is degree and another is percentage. For this case we will find the slope in degree. So for that case what we have to do is we will go to special analysis tool, and then inside the special analysis tool you will go to surface. Inside the surface you can see slope, and then click on slope. Our input raster will be our fedicola.tif, and we'll save this as slope.tif and then save. Okay, here our output measurement will be degree. You can also change to percentage, right? For this case we will go to it degree. The keep it as same, other value keep as same, and then we'll go with We'll click on OK. Okay, you can see our slope value from 0 to 9 degree, 9 degree to 15 degree, and ultimately up to 76.44 degree. We have different classes here. Now we can minimize the classes from properties and then change class value to 5, and then we are also label the feature label to, you can change the format label. Significant digit to maybe 5, and then apply. Okay, so in this way you can find the slope value. The higher slope value is given by red color and lower slope value is given by green color. This area have the lower slope and this area have the higher slope. So maybe this may be the area of plain land and this may be the area of hilly region. After that we will go with aspect. So what is aspect? Aspect gives the direction of the slope, which direction the slope is directed towards. It starts from 0 degree and ends at 360 degree. The 0 degree refers to the north, and then 90 degree refers to the east, 180 degree refers to south, and then 270 degree refers to west. In this way you can find the direction of the slope, and for that case we will also use the same DEM data. So we'll go with same. We have surface, inside surface we have aspect, and then I will drag. You can directly drag from here, or you can add from here .til, and then we'll go to output raster and save it at aspect.pif, and then save. Other will be same, and then click on OK. You can see different direction of the slope is shown in here. From 0 to 22.5 is given as north, northeast, east, south, southwest. Similarly, the flat terrain is given as the flat terrain do not have any direction, so its value is given as -1. So altogether we have 1 2 3 4 5 6 7 8 9 10 values, 8 values of different direction. Here north direction is repeated, and then 1 for flat. To total 9 values is given for the aspect. Similarly, you can change the symbology from symbology in properties. After that we will go with hillshade. So hillshade gives the illumination value, that is when the light falls on the surface of the earth, how the shadow effect is prepared, or what type of light the surface acquires. On the basis of that, the shaded region is created with the help of hillshade. So for that case we have two types of value. One is altitude value, another is azimuth value. The altitude value ranges from 0 to 90 degree, and the azimuth value ranges from 0 to 360 degree. So for that case we will go with same DEM data and then create a hillshade. We will input raster as Hedicola, and then output will save as hillshade.pif, and then insert as save. And then here you can change the azimuth value and altitude value. The altitude value ranges from 0 to 90 degree and azimuth from 0 to 360 degree. Default value is 315 degree and altitude is 45, and then we'll click on OK. Okay, you can see different what type of shadow is formed when the light falls on the surface from that azimuth and altitude. So this will create the hillshade of the raster data or DEM of that area. So in this way we have done terrain analysis on our DEM data. Now what we'll do is we'll create a contour from the CSV data that we have inserted before. So for that case, let me again insert that CSV data, Excel data, and I will show the XY value. History, northern and height. Then click on OK. So I'll go with zoom to layer. So this is our Excel data. What we have to do is, first of all, we have to create a DEM. DEM means we had before this DEM DEM. It is obtained from the elevation value which was obtained from satellite imagery. Satellite find out the elevation value on the difference of 10 meter or 20 meter or 30 meter, and then use interpolation technique to find whole elevation value, the whole surface. This way the continuous elevation was formed. But in this case, we have, for the case of Excel data, we have discrete elevation value, individual point of the elevation value, but we have to find the elevation of every point, individual point. This left out point are also be find out. So for that case, what we will do is we will do interpolation. For that case, we will go to special analyst tool, and then go with interpolation, and then we'll do it IDW interpolation, inverse distance weightage method. So we'll add the point feature as Excel data, and on the basis of height we will create the interpolation, and cell size will be the same as that of the previous, and then I will save this as Excel dem.tif, and then okay, number of points, how many points you have to take. We'll take 12 as the point, so it will create an elevation on the basis of 12 neighboring points. And then we'll create a DEM. So before we had the black and white type of DEM, now it is this type of DEM. We don't need to worry, we can change from stressed and then create this DEM. So like this way you can create a DEM data. Now what we have to do is we have to create a contour. Before creating contour, what is contour? So contour is an imaginary line which represents the equal elevation surface. For that case, what we will do is we will go with surface. Inside the surface we have contour, and then click on contour. So we will add the contour as input raster, and then we'll create the contour interval. We'll create contour interval, for that case 5 meter, and then click on base contour will always be 0, and then we'll save that as contour.tif, and then sorry, it is a feature class, so feature class will be dot SHP, and then okay. So here we have created the interval of 5, so only one contour is shown. Let me remove this. Let me see the elevation value. So it has the range from up to 60, 56 to 60, sorry, 52 to 51, 50 to 60. So let me give the elevation ranges from interval of 1. I'll save as contour 1.ssp. Interval will be 1, and then okay. So in this way you can see different contour value is shown. Now what we'll do is I will keep different color for different contour values. So I'll go with properties and then go to symbology and quantities, categories, and on the basis of contour I will add all values and give different color to different contour, and then I'll also label on the basis of contour value, and then enable label feature. So this way you can create a contour of your elevation value. Now we have completed working with raster data. So after that, what we'll do is we'll go with map layout. So for that case, we are in our data view, layout, data view. Now what we'll go with, you can see here layout view, or you can go with file, or you can go with view. Inside view you can see layout view. Here in first, what we have to do is we have to change the setup, our paper size, paper print and page and print setup. We'll go to print and page setup, and then we'll change the letter size to, we have size letter, we'll go with A4, and then we will go to the orientation as landscape. Okay, so I will change like this. What you have to do is we'll go to data view and zoom in, and then go with okay. Now this is okay. This is our map. The first thing what we need of our map is we need title. So for that case you go to insert, and then here you can see title. And what is the title? Slope of pericola, and then I will save this. Okay, you can double click on this and then change the symbol. You can increase the size, maybe 20. I will change that font to Times New Roman. I will make the style bold, and then click and then apply OK. So in this way you can change the title. Maybe I will increase the size of the map. Okay, now the next thing you have to add is you have to add north arrow. So that is, I will select this and add here, and I will increase the size of the north. After that, what we have to do is we have to add scale bar. So I will add this type of scale bar and then click on OK. The unit is miles, so I'll change this to kilometer, and then apply, and then click on OK. You can change the size from this and increase or decrease. Okay, after that we have to add its legend. So insert, go to legend. So what we have this pericola.tif. This is the legend item. Yes, this is pericola.tif. And then next we'll give as the title, and then border. We need the border for the legend as 1 point, and then next finish. So this is the legend of our map. You can increase from here. This is the legend. After that, what we have to do is we have to add some dynamic that is we have to give the data frame coordinate system. Okay, it will give the coordinate system that you have used in the map, that is coordinate system is WGS 1994 UTM 1044 projection transverse Mercator datum. Like this you can change. Okay, I will go with, I will increase the maybe I will increase the change the font to Times Roman. I don't need bold, and then click on OK, and then OK. So this way you can add, and also if you need some text, you can add text here. I will add prepared by GeoGraphics, and then save this here. If you need bold, this change symbol, change to bold, apply. Okay, after that what you have to do, we have to add some grid lines. For that case we will go to properties, select on the map and go to properties, and then go to grids and add a new grid. Next, so we'll make a grid on difference of 1 minute 40 seconds. Finish, and then apply. Okay, we can see the grid of the map. What we have to do is we have to change the way the grid have been saved. So we'll go to properties, and then labels. Here we'll go with top and left, and then OK, and then apply. Sorry, this is not the way. Top and bottom, maybe you can change accordingly. That's wrong way, so we have to change it to left and right, I think. Yes, this is the way, left and right. And we'll also change the label value in 9, size, and then I will decrease this value, so you can see now the map is complete. In this way you can add everything on the map. And one thing is we have to add a neat line. So neat line will be this, and place around all the elements. Background color will be none, and then we'll click on OK. So this way you can add neat line here outside the map. Now what we'll do is, what I will export. So go to file and then export map, and then I will save this in my output, where the polar slope, maybe this is not the slope, this is elevation JPG, and then say we can go to the folder and see the map prepared by you. So this is the map that we have prepared. So with this we have completed our basic tutorial on ArcGIS. Hope you find it interesting and helpful. After that we will create some tutorials on advanced GIS after some time. So thank you very much for watching this video. If you like